In this lecture, we will introduce working with attributes and methods for the child class. Defining attributes and methods for the child class. So once you have a child class that inherits from a parent class, you can add any new attributes and methods necessary to differentiate the child class from the parent class. So let's add an attribute that's specific to electric cars, a battery for example, and a method to report on this attribute. We will store the battery size and write a method that prints a description of the battery. This attribute will be associated with all instances created from the electric car class, but won't be associated with any instance of car class. So we define a class called electric car, same as in the previous lecture, but we add a battery variable called battery size, this attribute for electric car. So inside the diff initial function, self, make, model, year, this is same. Self represents this electric car, and make, model, year will get the pass information from the user when creating an instance of electric car. Then sup initial will connect this electric car class with its parent class, because we add a car in the parentheses when creating this class. So this make, model, year information will be actually passed to the car class, and in the car class this value will be assigned to the attribute of make, model, year. So we do not need to write make, model, year here in the electric car class in the initial function. We only needed to add battery size with the default value 70, because battery size applies only to electric car but not to other car, not to general type other cars in the car class. And in the electric car class, we also define a function called describe battery self. So this function will print information of how many battery size of this car. Then we can create an instance of electric car called my Tesla, and with an input make, model, and year information for this car. Then we can print out the information for this car with a dot notation. Get descriptive name actually is a method described in car class, because electric car inherits from car class, so it has every message came from the car class that can be used. But here we also can use a method only available for electric car to describe here, describe battery. So we can use dot notation, my Tesla dot describe battery. We show the battery of this car. So overriding methods from the parent class. You can override any method from the parent class that doesn't fit what you are trying to model with the child class. To do this, you define a method in a child class with the same name as the method you want to override in the parent class. Python will disregard the parent class method and only pay attention to the method you define in a child class. Let's say the class car had a method called fuel gas tank, and this method is meaningless for an all-electric vehicle, so you might want to override this method. Here is one way to do that. So inside the class definition for the electric car, we write an function with the same name as the function in the car class, in the parent class. So we diff fuel gas tank. If there are function called fuel gas tank in the car class definition, we also write a function called fuel gas tank in the electric car. But here inside the function we write a statement, print this car doesn't need a gas tank. So when you create an electric car instance, Also, we'll use the method dot notation for fuel gas tank. For example, we use my car dot fuel gas tank. You use, for example, Tesla, my Tesla dot fuel gas tank. Then this information will be printed out. This method will override the same method in parent class. And instance as attributes. So when modeling something from the real world in code, you may find that you are adding more and more details to a class. You will find that you have a growing list of attributes and methods, and that your files are becoming lengthy. In this situation, you might recognize that a part of one class can be written as a separate class. You can break your large class into smaller classes that work together. For example, if we continue adding details to the electric car class, we might notice that we are adding many attributes and methods specific to the car's battery. When we see this happening, we can stop and move those attributes and methods to a separate class called battery. Then we can use battery instance as an attribute in the electric car class. So we can create a battery class. Actually, battery class include information, its battery size, and the method called describe battery we have introduced in the previous page. And we can create a new method called getRange. So for describe battery is showed information of how many battery size for this car, and getRange will show information of how many range for this car. So if inside the function there is a conditional test, if battery size is 60, we will get range, for example, 140. And else if battery size is 85, we'll get range 185. So message also will be printed out for this battery size of this car. So we create we create a class called battery. Then next we can use this class of battery in the electric car. So inside the class of electric car definition, we will create a battery attribute. But here, battery attribute's value is an instance of battery class. So this battery attribute will have all attributes, sub-attributes, and methods of this battery class. So next we can create an electric car called my Tesla with the make, model, and year information. Then we can print its name. Actually, this method comes from the car class. Then next we can use dot notation to battery. So here the instance actually is a attribute of my Tesla's batteries attribute, but actually it's an instance of battery class. Because this is an instance of a class, so it has method. So this method describe battery will print out the battery information of this battery of this car. And we can similarly use the dot notation to end the battery attribute of this Tesla car. Because this battery attribute is an instance of battery class, so it has a method called getRange. So we use dot notation to call this method getRange to show how many range of this Tesla car. So in the electrical car class, we now add an attribute called battery. This line tells Python to create a new instance of battery with a default size of 60 because we are not specifying a value, and store that instance in the battery attribute battery. This will happen every time the initial method is called. Any electrical car instance will now have a battery instance created automatically. So here the attribute is an instance. Attribute is an instance of a battery class. But then we create an electric car and store it in the variable my Tesla. And when we want to describe the battery, we need to work through car's battery attributes and methods. So my Tesla.battery.describe battery will show information of this car's battery, and my Tesla.battery.getRange will show how many range of this electric car. We will show all these statements in Anaconda Spider. So we move to this file, section 8 classes, py, and source files link has been added to the description of this video. Then we move to lecture 4, working with attributes and methods for the child class. So add a battery attribute that's specific to electrical cars and a method to report on this attribute in electrical car. So we create this class electrical car, and with the initial function with self model make model year with input, and sup initial make model year to link to the parent class car. Then we define a battery size attribute for specific for electric car class with the value 70. Then we also define method describe battery specific for electrical car class here. So print information of battery size. We learn this to create this class. Then we create an instance of this electric car. The my Tesla is an instance of this electric. We can print out information, get the descriptive name, and describe a battery. And the first method is comes from the parent class definition, and the second is specific for this electric car. So information for the descriptive names output, and this car has a 70 kWh battery. Then we use instance as attribute. So we create a battery class with initial value for battery size with battery size. Here we put an default value with 60 for battery size. Then describe a battery is same method as before. Then getRange is a new method created here to show how many range of this car. So if the battery size is 60, the range is 140, and if the battery size is 85, the range is 185. Then information is printed out. So we create this battery class first. Then next, when we can create electric car class again, but this time the battery attribute is an instance of a battery class defined here. So electric car has an attribute called battery, but the battery is an actual instance of battery class, so can use all the methods and values in the battery class definition. So we learn this to create electric car class again. Then we create an instance of this electric car. Then we print its name information, Tesla model. Then we can describe its battery. Use the dot notation battery dot notation describe battery. Then we can similarly get the range of this electric car. Use the dot notation method dot battery dot getRange method.